Hello dear students, welcome back to my YouTube channel. So as you know that we are discussing modern physics. Today we will be discussing lecture number 3 on modern physics. Up to now we discussed only one topic, that is photon theory. In photon theory we discussed many points like energy of photon, momentum of photon. All these things we discussed in this particular lecture, and mass of photon. Okay, how to find the wavelength and the frequency of photon. Done. Now in this lecture we are going to start a new topic known as photoelectric effect, one of the most important and having the highest weightage in whole the chapter. So let us start now. I hope my screen is visible to you. Elevator. Okay. Now, as you know that my screen is visible to you, so today we will be starting lecture number 3. And in lecture number 3, the very first thing that we are going to discuss, that is photoelectric effect. That is what? A photoelectric effect. Photoelectric effect. I can write here in a short term PEE. What is photoelectric effect? What are all these things? We will just complete these things firstly. Okay. Basic of these things. We know one thing. What, sir? We know one thing. Let us suppose we are having a material like this. We are having the material like this. Done. So upon this material, if something is falling, okay. So I will write here something is falling and we are getting something out of it. So now I will write here photon is falling. Photon with energy, let us suppose E dash, it is falling, and here my electron gets ejected. My electron. Work function. Work function of my material, that means the minimum energy required to get the electron out from the surface is phi, work function, and my incoming energy is more than work function, so my electron gets out. So this electron is having a specific name as a photoelectron. Electron gets ejected due to the help of light, known as photoelectron. Done. And this is my metallic. You can write here, this one is my metal. Okay, this is my metal. Done. And this whole phenomenon is known as photoelectric effect. Photoelectric effect. That means if a light which is having energy more than the work function falling on any metallic surfaces, electron gets out from that metal surface. The whole process is known as photoelectric effect, and the electron which is getting out from the surface is known as photoelectrons. Okay, this was firstly carried by Hertz. Hertz postulate these things. Then we are having Leonard, second scientist. Linear proved the photoelectric effect by experimental thing. Then we got the Einstein. Einstein explains the Linear's experiment. Okay. So first we are having Hertz, then Linear, then we are having Einstein. Okay. Due to this experiment, Einstein confirmed quantum nature. Einstein confirmed quantum nature of light. Quantum nature of light. That is particle nature of light. Done? So this was all about the photoelectric effect in a very nutshell way, in a very quick way. Okay, now? So now, energy, we know that energy is E equals to h or E equals to mc square or hc by lambda, all these things, right? So now, here we are having some specific terms. Let us define those things. First of all, we will define work function. We will define work function. And the notation used for the work function is phi. Phi. What is it? It is a minimum energy required. Minimum energy required by electron to get out from the metal surface. And it depends on nature of metal. It depends on nature of metal. It is work function. Definition of work function. Work function is the energy. So it is also a type of energy. If it is a type of energy, so I can write now phi. Phi is work function, so I can write equals to h nu naught. And it would be equals to hc by lambda naught. hc by lambda naught or hc by h nu naught or hc by lambda naught, right? What is phi here? Phi here is work function. Phi means work function. H is Planck's constant. What is nu naught? Threshold frequency. What is lambda naught? Threshold wavelength. Done? Now, one thing that you need to remember and you need to get in your mind, and that is threshold frequency. It is the minimum value. It is minimum value of frequency below which photoelectric effect is not possible. And threshold wavelength is maximum value of wavelength above which photoelectric effect is not possible. So what we understand from this particular slide, that is, if we want to get electron out from any metal surface, we need to get some required energy to the electron. That is work function. So my photon is carrying some energy. That means some frequency, some wavelength. So minimum energy is directly proportional to the frequency. So the same sentence is the minimum frequency required to get out the electron from a metal surface is known as threshold frequency. But wavelength is inversely proportional, so you will write the maximum value of wavelength above which photoelectric effect is not possible, not possible. Clear? And you will find different names. You will find different names for what? For this one, different names. One name is cutoff wavelength. Cutoff wavelength. One more name is largest wavelength. Largest wavelength. Clear? Cutoff wavelength or largest wavelength. You need to remember these things, right? Why? Because in any numerical you will find anything, right? It is not compulsory you will find threshold wavelength. Let us suppose it is given as largest wavelength. And some points that you need to remember, those points are like, so I will write now, those points are like my phi. It is given as 12400 divided by lambda, but lambda should be in angstrom and it is electron volt, and it is equals to 4.1 10 to the power minus 15 nu naught, and it is also in electron volt. These two conversions you need to remember. Okay, one more is 2 10 to the power minus 25. These are some conversions that you need to remember so that you will get your answer in a very quick way. Suppose now, I guess this page is very good to you now. Okay, suppose I will give you some numerical. Suppose first numerical is, if my phi is 2 volt or 2 electron volt, find lambda naught and nu naught. Okay, so I know that phi equals to 12400 lambda naught electron volt. So therefore I can write lambda naught is equals to 12400 divided by 2. Done? And it will come into the angstrom part only. 2 ones are 2, 2 6 is 12, 200, 200. So therefore I can write lambda naught came out to be 6200 angstrom. 6200 angstrom. In the same way, if we want to find the nu naught, we know that phi is equals to 4.1 10 to the power minus 15 nu naught electron volt. So therefore my nu naught equals to phi whole divided by 4.1 10 to the power minus 15. It will be in hertz. So phi equals to 2, so I will write 2 divided by 4.1 10 to the power minus 15. I will write like as a 2 10 to the power plus 15 divided by 4.1. I will take it as approximately 4. 2 by 4, 1 by 2. It is 1 by 2, 10 to the power 15. So that means nu naught is equals to 0.5, 10 to the power 15, or I can write it as a 5. I will write as a 5 10 to the power 14 hertz. This is my second answer. Easy or super easy? Easy or super easy? I am not giving you too much of definitions thing. I am giving you the required one, then I am just getting the numericals done. Okay, now next numerical. Numerical like work function of sodium equals to 2.3 electron volt. Work function of copper is equals to 4.5 electron volt. Find lambda naught of sodium divided by lambda naught of copper. Done? Okay. We know that phi is equals to hc by lambda. H constant, c constant. That means phi is inversely proportional to the lambda. Phi is inversely proportional lambda. So I can write here. Sorry, it is inversely now. Inversely. So I can write here lambda naught of sodium divided by lambda naught of copper equals to phi of copper divided by phi of sodium. Phi of copper is 4.5, sodium is 2.3. Done. So you will take the approximation. It is 4 by, let us say 4 by 2. Okay, it will be answer 2 is to 1. So you need to take the approximation and you will get your values in approximation only. Done? Done? Easy? Easy or super easy? Okay. Now, let us start the Lennard's experiment. One of the important thing now. I will write here Lennard's experiment. Lennard's experiment. So I will make firstly the experimental tool. Here we are having a test tube. One second. So now here, I guess I make some mistake here. So here we are having a battery. It's my battery, variable battery. Here we are having an ammeter. Okay, reading of current. Now, so now I will make here a graph, voltage and current. I is current. This I means current. This I means current. This V means voltage. Voltage means potential difference. Look now. Here some rays fall on it. Okay. Some rays fall like this. And these rays eject some electron. These rays eject some electron. Okay. Now, sometimes these electrons, they're having some, look, these electrons, sometimes this electron is having kinetic energy. So this electron will reach up to this particular point. Okay. This electron reaches this point. So that means now current will flow. That means now current will flow. Okay, without giving any kind of external voltage source, my electron is flowing, so that means my current is flowing. So this current that is flowing known as photocurrent. Photocurrent. Sir, why photocurrent? Because the current is flowing due to the photoelectron, that is why it is in the photocurrent. When my potential is zero, when my voltage is zero, still the electron is crossing. So it simply indicates when my potential is zero, my current is not zero. So my current is somewhere here, right? Then I am increasing potential, my current will increase up to a certain level that it will become a saturated. So this line is a saturation current, IS. IS means saturation, saturated or saturation current, saturated current. This state is known as saturation. Okay. Do you know the reason why? Look now. First of all, we are not applying. Firstly, we are not applying any potential differences, but still, electron, due to its own kinetic energy, it crosses the barrier and it completes the circuit. Without applying any potential differences, we are having some current in it. That's why graph starts from the positive, right? Then we increase the potential. We increase potential. If we increase potential, this side is positive and this side is negative. So my electron gets attached towards the terminal, this terminal. When I increase the more potential, more electron gets in. Let us suppose, firstly, if we are having 100 electrons, 100. When my potential, let us suppose, is 2 volt, I am getting 70 electrons to my positive terminal. Now I increase my potential to 4 volts. I am getting 90 towards my positive terminal. When my potential reaches 6 volt, I am getting 100 at my positive, right? When I increase it to the 8 volt, nothing happens. 100% electron will reach here. You can see from the figure only. You can see from the figure only, right? You can see from the figure only. Look now. It starts from this point. It starts from this point. It starts from this point. You can see now it starts from this point. Look now. It starts from this point. Okay. When it started from this point, now we are increasing. Now, firstly, it is 70%. Okay, we increase it 70. Second, 90. So it is going to 90. Now, third point, 100. So it reaches 100 here. Now, if you are increasing it above the 6, you are getting to the 8 volt. Now, nothing happens. Saturation. Why? Because 100% electrons are reaching now. That's why it is not showing any sort of variable things. So that's why we are having what? Saturation current. We are having saturation current, and this particular phase is known as saturation. It is not important, but still I'm giving you. Then done now. Look now, one more thing that you need to remember, that is if let us suppose we change the battery, if polarity of battery is changed, what happens now? This is my test tube in this way. Okay, now I change the battery. Change the battery. Potential here is V. So here potential will be negative. Here potential is positive. Now what we observe from this figure, we observe that electrons are coming. Electrons getting ejected. Okay. But look now. This negative repulsion, and it will stop. This negative and this negative, it will stop. Current I, potential V, potential minus V. Now my potential is minus V. Now when my potential is minus 2 volt, we are getting only 70% electron at my negative end. When my potential is minus 4 volt, we are getting we are blocking 90% electron. It is blocking 90% electron towards my negative potential. When my potential reaches to 60 volt, now I am able to control my 100% electron. No electron is reaching this potential. No electron. If no electron is reaching, so can you tell me what is the current through the wire? Sir, current will be 0. Why? Because current is only present when electron is reaching this. If electron goes up to this particular point, then it returns back. So no electron reaches this point. If no electron reaches this point, so no circuit complete, so my current is 0. So I will make the graph once again now. Look here. So this is my positive potential. Now I increase my negative one. The graph looks like this. And this particular known as V naught, minus V naught, and it is specific name as stopping potential. Stopping potential. So stopping potential is that value of potential at which my electron stop reaching. My electron stop reaching the negative terminal of the battery, hence the current in the wire is 0. When the current is completely blocked by the potential, that potential known as stopping potential. Easy? Easy, no? So you will write here potential. You will write here potential at current becomes 0. Potential at my current becomes 0. Easy or super easy? Is this easy or super easy? I know sometimes my network gets stuck now due to the flood kind of situation is right out there. So, but I hope that you can bear this kind of things, right? Okay. One more thing that you need to remember, and that particular thing is, look, from work power energy chapter, work power energy. That is work energy theorem, which is work done by all forces equals to change in kinetic energy. It is kinetic energy final minus kinetic energy initial. Work done by all the forces here is, it is minus EV naught. Do you know why? Work done by electric force. By electric force. I will write here minus EV naught equals to, at the end my electron stop, that means 0, 0 minus kinetic energy max. Initially it was at max, right? I will write minus EV naught equals to minus kinetic energy max. So cancel out. So therefore, my EV naught equals to my kinetic energy max. This equation you need to remember, that EV naught equals to kinetic energy max. Done? Okay, on the basis of same, so we are having a numerical. That is, if kinetic energy max of any electron is 5 eV, so find potential, stopping potential. We know that EV naught equals to kinetic energy max. I will write EV naught equals to 5 EV. EE cancel out, so my stopping potential came out to be 5 volt. Easy or super easy? Shortcut way. Shortcut. Easy? Easy or super easy? Easy or super easy? Okay. Now, next part is effect of intensity. Effect of intensity. Keeping frequency constant. Keeping frequency constant. Frequency means energy. Done? So what is intensity, sir? Intensity is NH nu divided by AT. Done? Is it so now? So you can see now, sir, nu is constant, H constant, area constant. So therefore you can write here, intensity is proportional to N divided by T, which is proportional to the N. So what is N here? N is number of photons per second. Done. So if N increases, that means my intensity increases. And if intensity increases, my current will increase. Yes or no? So therefore, you will write here, intensity is directly proportional to my current. If you need to make a graph out of it, so I will just show you how you need to make a graph out of it. It's my graph. And this graph is between my current and my voltage. Yes, no, by my potential. No, by my intensity. Why? Because here we are finding intensity. Look, we are having here intensity and current. So my graph will be between intensity and current. And if it is directly proportional, so my graph will be straight. This is my graph. Straight line graph. My straight line graph. Okay. So these graphs you need to remember. Why? Because you will get a theoretical numerical from these particular portions. So what is the effect of intensity on the photo current? You will say that, sir, my photoelectric current will increase, that it is directly proportional to the intensity. Why? Because intensity is directly proportional to the number of electrons per second. If the number of photons per second increases, intensity increases. If intensity increases, so you will say that my current will increase. So it is directly proportional. Easy? Okay, now one simple numerical. Simple and short numerical. Simple and short numerical. I will show you two graphs. Okay. Intensity I2, intensity I1. This graph is between my voltage and my current. Stopping potential. So you have to tell me whether I1 is more than I2 or I2 is more than I1. Done? So by this particular numerical, you conclude that, look, stopping potential is same. Stopping potential means frequency. So my frequency is same. So here, if you can increase it, so it is VI, it will be current I1. Here, I will be my current I2. And you know that current is proportional to the intensity. So you can see here, sir, I2 is more than I1. So therefore, intensity of second is more than intensity of first. Easy or super easy? Easy or super easy? So I guess these are very super easy things, right? Yes, I am teaching you, that's why these are some super, ultra super easy things. Okay? Easy? Now second one. Second one is effect of frequency now. Effect of frequency of incident radiation. Keeping intensity constant. That means number of photons striking per second is constant, but increment in the what? Frequency. If there is an increment in frequency, so you will write energy increases. If energy increases, you will write that you need to have more stopping potential. more stopping potential. Done? Look now, so my graph, it looks like this now. My graph, V and I. One graph, second graph, minus V naught 1, minus V naught 2. So therefore, minus V naught 2 is more than minus V naught 1. But here, my current is same. Why? Because look now, current, the current is depending on the number of electrons. So here, number of electrons is fixed. If number of electrons is fixed, so you will write my current is fixed. So my current is constant, but what increases now? In energy increases. Energy per electron increases. If energy per electron increases, so the stopping energy also increases. Stopping energy to electron also increases. If that thing also increases, so therefore you will write now V naught changes. V naught changes. V naught changes. Easy or super easy? Easy or super easy? Okay. Last numerical of the class is last numerical. So last numerical is like, look. A, B, C. So look now, the potential of ABC is V naught 1. Here is V naught 2 minus. So you will write now frequency of C is more than frequency of B and frequency of B is equal to frequency of A. First thing, current I, here is I2 and I3, it is I1. So you will write now I2 is equal to I3 and I3 is more than I1. So therefore you will write intensity I2 is equal to intensity I3, but it is more intensity of I1. So this part of numericals you can find in your examinations. That's all. Nothing more difficult from these things. Okay. So what we studied up to this particular point, we studied only this graph. That means what is the effect of intensity? Intensity is directly proportional to the current. But second one is effect of frequency. Frequency is equal to the change in your stopping potential, not change in your current. Niship, sir, I am in ninth. But if you are in ninth, no. So what you will study from this class? The class is designed for 12th only, right? If you study, if you want to study now, you're most welcome. Okay. So I guess we are done with today's class. So thank you. Okay, so total number of classes that will take for this chapter would be 8 to 9, and we are completed 3 classes. Now within 5 to 6 days, we will complete modern physics. 6 days in modern physics. In next 3 to 4 days, we will complete semiconductors. Then we are having optics. I don't give you any deadline for optics then. Okay. After optics, I will start 11th. 11th, motion in 1D. That means kinematics. And one important thing that you need to remember, and that is, one second. one most important thing that you need to remember now, beta. One second. That is first basic maths, second vectors, third UND. If you can check my YouTube channel, you will find one short video. You will find one short video on these three chapters. You need to finish these three, because I will start them from the kinematics only. Okay. So for today, we discussed more than enough. So let us just hope for the best for our upcoming your examinations. And thank you, Veda. Thank you very much. Bye. Thank you.